My name's Bruce Top. I'm a professor working at QUAFI, the University of Queensland, and based at the Marucci Research Facility. The macadamia industry is a really important industry. It's got about 800 growers, and it has 75% of the crop is sent export, and the export value of the crop is about $300 million. So the priorities are to produce new cultivars that are more profitable for the industry. A lot of the cultivars that we have are 50, 60, 70 years old. The industry has changed over that time period, and we need new cultivars that are adapted to the methods that are used for farming now, and also adapted to the changing environment. So we're looking at ways of improving the breeding program, making it more efficient. With the genomic selection, what's happening is we're actually using predictions from the DNA of the plants to predict what the important characteristics such as nut and shell yield and tree size and kernel recovery are. And this is the first time we've actually used it in the breeding program in a practical sense with this orchard here. The idea here is that we will only have the trees in the ground for 5 years, and we will make our selections within that 5-year period, and the elites will be clonally propagated and sent out to growers for testing at different locations. With this method of the genomic selection and genomic prediction of the elites, we're anticipating that eventually we'll be able to do this in virtually half the time, to about 12 years. Our progeny trials, we established them in warmer climates in locations such as Rockhampton and Emerald. In 20 and 30 years' time, the selections we're making now that are adapted to these warm climates such as Rockhampton will be really useful where the commercial areas around Bundaberg and Northern Rivers are now.
My name is Mubashir Alam. I'm a Senior Research Fellow at Centre of Horticulture at QUAFI, and also Advanced Queensland Industry Fellow. In this project, I'm aiming to do 3 things. First thing is to develop a low-cost genotyping platform. Currently, the cost of genotyping is around $50 to $70 per sample. And in this project, I want to reduce the cost to $10 to $12. Another thing is we want an accurate selection strategy. As Bruce talked about the genomic prediction or genomic selection with the support from artificial intelligence, machine learning and deep learning. So instead of using conventional statistical models, we would also like to use large data set and get support from AI that can help us to predict genetic value. And the final thing is to develop an efficient breeding strategy combining all together.